So we're starting a new unit today on radical equations and radical expressions. For today, I really wanted to review properties of exponents. This is something that you should already know, but I've listed 7 properties here. You can only see 5 right now. Take a minute, pause, write down these 5 properties, and then I'll move the paper. Okay, so moving the paper up. Here's 6 and 7. So these are all of the properties of our exponents. To talk about these just for a minute, and then we'll get into some examples of how to use them. Anytime that you have a base, this is considered the base of your property. So all of these A's and B's, A and B are bases. The first thing to note is all of these things, for all of these properties, A's and B's are bases. The exponents are M and N. So just looking at these, we have A to the 0 power is equal to 1. So anything that is raised to the 0 power, this could also be B, is always equal to 1. If we have multiple bases in a problem, there are 2 of them listed. Otherwise, we're just going to utilize A. Noting for the second one, it has A to the negative power. If A is to a negative power, it can be brought down in a fraction and that power made positive. Or if it was negative in the bottom denominator of the fraction, it can be brought up to the numerator of the fraction, which is what this is right here, without it being in a fraction, and made positive as well. So if you ever have a negative exponent, there are ways to fix and rewrite your exponents so that they are positive. Now, A to the mth power times A to the nth power, we add our exponents together. Now, we've been doing this for a really long time. X times x is x squared because you add the exponents of 1 and 1. X squared times x is x cubed because you add the exponents 2 and 1 and get 3. The same thing is said for if we're dividing those bases with the exponents m and n, we would subtract our exponents. So if you're multiplying, you're going to add. If you are dividing, you are going to subtract. Now look at this. If I have a, b to the same exponent, that's the same thing. If we're multiplying a and b, not adding, multiplying a and b or dividing a and b, then we can distribute that exponent. That's the only time that you can do that. Please note that this is not the same thing as ab to the nth power. They have to have parentheses in order for it to be able to be distributed, okay? So this is not the same thing. And you cannot do this for a plus or minus b to the nth power. This has to be expanded and FOILed. Okay, so that's for these. This last one is really important as well. I would say that this last one, the second one, and 3 and 4 are going to be really, really widely used in what we do today, but all of them are very important. A to the mth power to a power of n is when we multiply our exponents together. This is the only time that we multiply exponents together, is when we have a power to a power. So this case is when we have a power to a power. So a power raised to a power. That's the only time that we're going to multiply our exponents, okay? The other thing that you need to make sure you note is that for these two up here, they have the same base. The same base. This is really important because if you don't have the same base, you cannot combine the exponents, okay? So please make sure that if you're adding and subtracting your exponents, you have the same base and you're working with the same base. Like I couldn't take an x squared and a y squared and add their exponents together because the bases are different. So if the bases are just numbers, it's the same concept, but you have to have the same base. Okay, so what we're going to do is a couple of examples of this. Let's go to our first example. Go to the next page. For example, let's say I have 5a to the 3rd power times negative 3a to the negative 5th power. Now, you're going to do this in stages. I have the same base here for both of these. So what I'm going to do is I'm going to very quickly multiply. We can multiply them together and add our exponents, or we can kind of do some adjusting before we do this. So one thing I want to make sure you note is that when you're looking at this, the first thing that I realize is I have a negative exponent. And then anytime I have a negative exponent, I can bring it down in a fraction and make that exponent positive. So that's what we're going to do here. By adjusting this and making this a positive exponent, it's going to make it easier to work with. So we're going to take 1 over a to the positive fourth power instead. So now I have negative 3 times this, and then 5a cubed is going to stay the same. Now, what I would do now is I would just multiply that negative 3 to the numerator, because it's kind of like having it be over 1, multiply it to the numerator. I have 5a cubed times 3, negative 3, over a to the fourth. This 5a cubed also can go to the numerator because this can be said as being over 1. And we multiply these together. 5 times negative 3 is a negative 15a cubed divided by a to the fourth. Now I have division. So up here I had multiplication, and I could have added my exponents together and done that first. But I went the route of fixing that first, and then we're going to multiply. And then now we have a division problem. So when I have exponents that I am dividing, I'm going to subtract my exponents. That's going to look like this. Negative 15a to the 3 minus 4. Now 3 minus 4 is negative 1. So I have negative 15a to the negative first. And now I'm going to once again use that property where I bring down that negative exponent. Now you do not bring down the 15. The 15 stays in the numerator. It stays negative 15. The only thing that gets brought down is that exponent, and it's made positive. My final answer here should be negative 15 over a. Let's do another example, kind of similar but a little bit different, so that we can kind of get the hang of this. Sometimes I do this step first, and sometimes I do it last. I really don't know the best procedure here. It's just whatever you're comfortable with. So give me 1 second and I'll have the other example up on the board. So I went ahead and wrote the next 2 examples on the board. The first one, here's the thing. It's kind of important for you to kind of do this in an order that makes sense. If you're looking at this problem and you see this exponent on the outside and that's confusing you, the first thing that I would do here is, because all of these are being multiplied together, I would take that exponent and I would distribute it. Now, one thing to note is when you have a power raised to a power, that's when we multiply. But what I'm looking at here is I have negative 4 to the power of 2, x to the negative third to the power of 2, and y to the fifth to the power of 2. So if I'm going to do this in stages, I'm going to show you all the steps, okay? So this negative 4 to the power of 2 is 16, times x to the power of negative. This is where I multiplied those exponents. Negative 3 times 2 is x to the negative 6. So that's one of those properties. Anytime you have an exponent, a power raised to a power, we multiply. Same thing with y to the fifth to the second. That would be y to the 10th. Now, when I'm looking at this, my final answer cannot be left with negative exponents. Because I have a negative exponent, I'm going to want to fix this. So we're going to have a fraction for our final answer. Anything with positive exponents should go in the numerator of my fraction. Anything with negative exponents will go in the denominator of my fraction and made positive. That is how you're going to work that procedure. Okay, anything that goes in the numerator and anything that goes in the denominator. Okay, so if it's a negative exponent, it goes in the denominator. If it doesn't have a negative exponent, it stays in the numerator. And that's my final answer. Looking down here, it's kind of unclear sometimes what to do first. I work it piece by piece. I do the 4 divided by the 2. Then I'm going to work a over a to the fifth. Then I'm going to work, and notice I'm doing this, in stages, b to the 6 over b, and c to the third over c to the third. So if I do this, I'm going to work all of them separately in my mind, and I'm writing out the steps just so that you have all of them, but that's what I would do in my mind. So 4 divided by 2 is 2. A to the first power minus 5, so I take the numerator minus the denominator, exponent, b to the 6 minus 1, and c to the 3 minus 3. Simplify my exponents. I have 2, a to the negative 4th, b to the positive 5th, and c to the 0 power. So remember, anything that has a 0 power as an exponent, that equals 1. So this actually goes away because it equals 1. So now what's left over, we have a fraction. And I know I have a fraction because I have a negative exponent at this answer. So my kind of final step here is to see if I can bring anything down in the equation or if it all just stays the same. If none of these exponents were negative, then my answer would be just what is written. But in this case, I have a negative exponent. So that negative exponent gets brought down, made positive, and then everything that does not have an exponent that's negative stays in the numerator. So 2b to the 5th over a to the 4th, my final answer. Now my very, very last example that I wanted to show you guys before we stop this video is right here. For this problem, I have a squared b to the 3rd over a b to the 4th, all to the power of negative 1. Now here's the thing. There's a couple of things that I could do here. Okay, I could distribute that negative. I could not distribute the negative and work on the inside first and then do the exponent last time, or there's a third option. So I'm going to kind of show you 3 different ways to approach this problem. The first one being, let's distribute the negative to everything. So this is kind of a messier route, but I have a to the negative 2nd, b to the negative 3rd, over a to the negative 1st, b to the negative 4th. To continue this process, I would take a to the negative 2nd and a to the negative 1st, and I would subtract the exponents. So I have a to the negative 2nd minus a negative 1 is going to give me a positive here. And then for the b's, it would be the same thing, negative 3rd minus a negative 4. This is why I wouldn't prefer this method, because it gives you kind of a lot of negatives and it's a little messy. But here I have a to the negative 2nd plus 1 is a to the negative 1st. b to the negative 3rd plus 4 is b to the 1st. So my final answer would be a fraction and b over a. Now that's one way to look at this problem. The second way to look at this problem is by doing the subtraction of the exponents on the inside first. So if I did the subtraction on the exponent or the exponents on the inside first, I would have a to the 2nd minus 1, b to the 3rd minus 4, all to the power of negative 1. Doing this would give me a to the positive 1st, b to the negative 1st, raised to the negative 1st. And then I could distribute that negative. And if I distribute that negative now, I would have a to the negative 1st, b to the positive 1st. I know it's, bear with me, it's an interesting problem. And that would give us the same thing that we had before with that b over a. Remember, the negative exponent goes in the denominator and it's made positive. So that's another route that I could have taken. Maybe you think that this one is less messy. I agree with you, it is less messy than the first one. But my preferred route here would be this. Remember that if you have a negative exponent, that you basically are taking the reciprocal. You're moving whatever is in the numerator to the denominator, and vice versa. You're moving whatever's in the denominator to the numerator. So one way to fix this is to create a fraction that's here. So a b to the 4th would go to the numerator, and a squared b to the 3rd would go to the denominator, and then we can complete the rest of the problem. So if I subtract these exponents, I'm going to take a to the 1st minus 2, which is going to give me negative 1, b to the 4th minus 3, which is going to give me b to the 1st, and that is once again going to give me b over a. So there's 3 different ways to do this problem. All are correct. I'll get you to the correct answer, and it's really up to you which one you prefer. So the assignment for this is going to be classwork number 1 in the new unit for radical equations, okay? Please make sure you're keeping up with due dates. and I hope you guys have a great day.